Hello everyone, my name is Neha and this is the 12th lecture on Introduction to Microcontrollers. In this lecture, we are going to learn about the program for rotating LEDs. So far, we have covered a program on blinking LED and we also covered instruction sets which are used to create the program. So by this point, if you understand those instruction set and if you were able to understand how to write a program on MPLAB, then you can easily create the program for rotating LED. And these rotating LEDs are the LEDs which I'm talking about are inbuilt on the development board, and we are trying to rotate those LED in sequence. So there are multiple versions of this program you can create using the 49 instruction set which are there in the microprocessor 16F 18875, and if you're using PIC 18, then it may have like more instruction set. So you can utilize those instruction set into your program and create a code for rotating LED. So this is the block diagram, or you can say flowchart for rotating LED, and it's very simple to blinking LED, and the only difference is that I've added this block. So I'll just go walk you through from the beginning. So start the program, turn on the LED, wait, which means providing the delay. So by this time, LED is already turned on, and this wait will provide some delay, which means that a LED will be turned on in that position for some time, and then LED will be turned off, and then again a delay is provided so that the LED is turned off for some time, and then after that the next LED will be turned on, which is on the left hand side of left side in a sequence. So the left LED will be turned on, and then so on. It will provide a delay and then turned off and then wait, and then another LED on the left will be turned on. So you understand the LEDs in the sequence, they will be turned on in the left position. So, and then this process will go in a loop. So this is the simple block diagram, and again your block diagram could be different than mine, and so try to create a flowchart or a simple algorithm of before writing any program. Now next thing is this a resistor which I have used for my program. I have used a resistor which is at address 0x26, and this resistor is a general purpose resistor which is you can find in the bank 0, and I have labeled this resistor using this EQU directive, and the label for this general purpose resistor is LED. So if you want to learn about how we can use the general purpose resistor, you can read this. EQ is assembler constant, and this comes under the assembler directive, and you can basically use this to define a constant. So we picked up 0x26 general purpose resistor, and there are a lot of general purpose resistor in that bank, so you can pick any one you want, and they are 8-bit resistors, and you can utilize those resistors into your program. So I picked this one, and what else I will be using in my program are these two instruction sets. So I'll be using move F. We already learned about this instruction set, which means moving the content in the resistor F into a certain location, and that location is defined by this D. So if your D is 0, if you put D is equals to 0 into your program, which means you're trying to put the content into the working resistor, and if you use D is equals to 1, it means you're trying to put the content into the file resistor. Okay, and then so this was the syntax, and then an example is given. So for example, move F FSR is a resistor, and comma 0. So here we have defined 0, which means the content of the FSR will be moved to the working register. So so after instruction, W is equals to value in FSR register will be placed in W, and in this case the status which is affected is this Z. So this status will be affected, and that's why this is equals to 0. And then we'll be using this instruction set, and we have again this discussed already in this instruction set in the previous lecture, but I'm going to briefly go through this. So this is rotating left F through carry, and then F comma D, where F is your file register and D is your where you want to place the data. Okay, so and this is, since we are using rotating left, so it's going to rotate the data in this way, where C is your carry flag, which will be affected in this case. So you are trying to move the content of file register into in this direction. So let's see an example. RLF reg1 comma 0. So before the instruction, let's say if your register has this value, this 8-bit value into the register, and your carry flag, it has 0 value. So what will happen if you run this instruction set? So after this instruction set, what will happen, the data in this RG1 will be moved towards left. So if you see on the leftmost side, we have 1. So just imagine if this data is put over here, and then this is C0, then this 1 is going to move here, and then whatever the 0 was here is going to move towards here. So you can see the same thing has happened. So after instructions, RG1 is going to remain the same, but in the working register, since you are putting here 0, you want the result to be saved in the working register. So the result is going to reflect here in the working register. You can see here that this this data has been moved towards left, and you can see that previously we had this register value, and then this will move to the carry. So this, whatever is there, is going to move it to the carry. So that's why your carry is now 1, and then carry was 0, so carry 0 is going to move here. So that's what you see here, a 0 here, and then rest of the data you can see has been moved towards left. Okay, so that's how it works, and we are going to utilize these two instruction set in our program. So now directly jumping into the program, this is the main code for rotating LED. So let me walk you through to this code. So we have used this general purpose register, and we are going to see where we are going to use this. This is my main program, start. So starting with bank cell select port A. So clear F port A, if there is anything there in the port A, so we are going to clear that up. And then bank cell trace A, making the port A as output. So you first select the bank cell trace A. So you selected the trace A, and then now you're clearing it up. So when you clear the trace A, it means you're providing 00 hexadecimal to the trace A, which means you're making all the bits in the RA register, which lies under port A, making it as all as output. Okay. And if in case you want to make just one bit as your output, then you have to specify which bit you want it to be output. Okay, but we are generally making all of the bits as outputs, and that's why we have used this instruction trace clear F trace A. And the next step is move LW. And then moving this literal number, this is hexadecimal number, into the working register. So move literal number to the working register. So we have used this instruction set to move this literal number, and then move whatever is there in the working register to the file register. Okay, and now my file register which I have picked up is this label LED. So this LED is defined at this address 0x26, which is a general purpose register. So So I'm moving this 8-bit data into this LED, and then the main code says that move F LED comma 0, which means the content which is there in LED has been moved to the working register. So you remember when D is equal to 0, the destination is W register. So what you have in the LED, you have this literal number. So this literal number has been moved to the working register. Now next step is move WF, which means move the data in the working register to the file register. Okay, so moving this data which is stored in the file working register to the file register, which is here, to the port A, and then call for delay. So I have not put the code for delay here in this slide, and I have explained the delay code already. So you are going to use that code, and if you have created your own delay code, then you can use that. So you will call for delay, okay, and then what will happen? So during this time, what will happen? Your this LED, which is what position is this? If you count from here, you remember we had like 8-bit registers. So this is, I'm going to use this pen. Okay, just pen. So you remember, so I'm just trying to make this over here. So this is your, do you remember you had RA0, RA, and then counting till RA4, and then RA5, RA6, and then RA7. Okay, so I hope you remember that this was our registers, 8-bit registers in bank A or port A, sorry, bank 0 or port A. So in port A, these are the 8-bit register you have starting from RA0 to RA7, and the 4 LEDs which you see on your development board are RA4, RA5, RA6, and RA7. And that's why you see here we have provided one. We have set this bit, which means RA4 we have set. So during these two like steps, what is happening that you're moving the content, this content to the port A, and when you move this content to the port A, then what is going to happen? This is going to turn on this LED. RA4 is going to be turned on. And then when it is turned on, and then what we did, we have called for delay because we want it to be turned on for some time. Okay, and then when this LED will be turned off, okay, we want this another LED should be turned on. So when this is on and off, then this should be turned on, and then this should be off, and then this should be on, and then this should be off, and then this should be turned on, and then off, and then again it should follow this sequence. So that is what we are trying to achieve. Okay, so call for delay, and then the next thing we want is to rotate the LED, and that's why we have used this instruction set. RLF, rotate the LED to the left, LED comma 1. Now if you notice that we have used 1 here, which means we are trying to store the data in the file register. And what is our file register? File register is this one, LED1, sorry, LED. So in this LED we want to store the data, rotating the, we rotated the bit and the data is stored here. And then again what will happen, go to the main. So what is the main label? Main label is there. So now we will now this after this step it will go here and will do the same thing. So the data, so your bit has so next bit on the left has been turned on, and now whatever the data you have in the file register is going to go into the working register, and from working register to the port A, and then what will happen, this LED will be turned on, and then again delay is provided, and the next step is to rotate the LED to the left again. So the next LED, which means RA6, will be turned on, and then it will follow the step. In this step it will be turned on, and then in the next cycle RA7 will be the bit will be rotated towards the RA7, and then this will be turned on. So you understand that how a loop is created, and then these LED will be turned on in sequence. Now in the next slide, I'm going to show you the code which I have written for this program. So this is the code, and I have used these general purpose registers which are at these three different addresses. I used R0 at 0 cross 2 0, R1 at this 0 cross 2 1. So these R0 and R1 I am actually using in my delay code, these two registers. And then I'm using LED EQU 0 cross 2 6 at this address for my main code. Okay, so here starts my program: bank cell port A, clear F port A, bank cell trace A, clear F trace A. And then I'm going back to the previous slide. So this program which you see moved this literal number, these two steps I've put into a separate label. So that's why you see here INIT, or under this label I've put these two steps to make it more clearer. So what I'm trying to do is to put this literal number here, and then moving it to the LED, and this is my main code. It's the same thing which you saw in the previous slide. Move F LED comma 0, move WF port A, call for delay, and then when it calls for delay it will go here and it will follow all these steps. So I'm not going to discuss what is happening in this delay code, because we have already covered for now. So just know we are providing the delay, calling the delay, and this delay code will run, and what will happen, it's going to come back here once the delay code is completed, and then it will rotate the LED to the left, and then again it will go to the main program, and this process will continue forever. So you can see here the loop will be run forever. Now next step is for you is to run this code, write this code on the MPLAB and try to run it and see how your LEDs rotate on the development board. And if you do that, then you will find a shortcoming in this program. And I want you to figure out this shortcoming by yourself. And if you feel there is a shortcoming, then try to fix it on your end. Try to change few settings in the program and make it more consistent. So this is the end of the lecture. Thank you so much for watching.